In this video, I will show you how to use the IgorPro template and why we save the file without X and why we have all of this long name, additional naming for the IgorPro. So firstly, I prepare, usually as a conventional practice, a separate IgorPro folder for all IgorPro files. And then I have one template that I usually copy and paste. So I keep at least one empty IgorPro file. Even though the file is empty, it consists of the routine of the file opening routines. So I keep it so when I need a new data set, I just copy and I rename. For example, in this case, it will be example 1. And secondly, I will create the folder with the same name, example 1. In this folder, I will put all of the files that I will work with in this IgorPro file. For example, in this case, I have nematicity maps without X. So as you can see, when nematicity saved with X, it has with X. Without X, you see no X. Additionally, you can check it either in the notepad or in the origin that you can see that the first column is directly my fluence and then my data. And if I check, for example, this file, I will edit in Notepad, the first column is X. It's very important to make sure that these files do not have the X column. So I copy, I paste in the example. The second important note is that if you look closely, you see that even though that was the same measurement, the final X has little difference between those two. If this is, let's say, 1.565, this 5 corresponds to femtoseconds, then this is 100 attoseconds sync, that is 0 is to tenths of attoseconds. So you see that here is I shift by 10 attoseconds this file, this lastX, and here by 20 attoseconds this file. And the reason behind this is if, let's say, I put the same number here and let's firstly put the same number and try to open with IgorPro, and then we see the idea behind this negligible shift. This is what you see when you open IgorPro. So this is a IgorPro window. So it's entirely on the screen. While when it opened, you need to choose, click on load text files and choose the first option. Out of these two, only the first option works. And then in this window, you choose browse and you go to the folder, where in my case, it's example 1 is the created folder. Okay, and I choose OK, and it will load and plot all of the 3 files. But if you look closely, all of the 3 files ended up being basically the same file. And the idea behind it is that IgorPro puts in the name of the file the last X and the last Z, the last power. In this case, it's influence. It was example case. Those values are unrealistic, but for the example, how the program works, it's fine. So it did not work. It's actually opened 3 images, but if you look at dataset, it saved only 1 file. So in this case, I go back and I rename the files. So the convention is that the second channel got plus 10 attosecond, and the difference gets plus 20 attosecond. It does not affect the result, considering that our experimental resolution is 1000 times less. In this case, I load, I choose the same folder, and right now you will see that even though these images, they're basically the same image of the same file, then I can close them. So now when I see, I will have first channel, I have second channel, even though it does not see that it's a big difference between them, and then I have difference. I can modify the image. For example, here I will put the same color scale based on the first channel, and here I will put the same color scale to maybe see the difference a little bit better. Still, the difference is you can observe there's quite some difference at the lower fluences, and that constitutes the fact that we indeed opened different files. And the same procedure, we can close it without saving. Let's show another example that the same procedure goes for two temperature model files, that after the temperature model produces a lot of files, you can find the files for IgorPro. Here, for example, shifted data, IgorPro temperature files with X, files stress. So you can go and let's, for example, go temperature of electrons, TEL, temperature of lattice, and then fit of the data, difference, and then everything in every file available. Copy into example 2. If you look closely, there is also a naming convention that I do little shifts. In this case, it's also by tenths of attoseconds, so the files do not repeat. And the procedure is the same. I copy the empty file, I rename it into the example, or into, usually you want to rename it into something more informative, like to temperature model or power dependence of that date or this date. And then, as you can see, I can open all of the different files, and here they are. Here, this is the difference between the experimental data and the temperature model. This is model data, and sometimes you can see just by looking how the file looks. Sometimes you need to look at the code. For example, here is 6750. For 6750, we go here and we find that is stress lattice 6750.